are you doing tonight?
I'm good. How are you?
I'm good. So it looks like we're going to be working with the sinusoid function tonight.
Yes. Well, these are just notes, but I talked to my teacher, and he just kind of wants us to do like a preview of it, just so I'm kind of up to date in class.
I think I can help you there with making up problems and stuff.
Okay.
Let's start with the standard. And different school systems have different standard general formulas, so you're going to have to tell me if this is what you use or not.
It looks familiar. I think so.
Right there. Other schools might have the B inside the parentheses, and that makes a big difference. That's the only thing that really makes a big difference. And I've actually seen it where some schools use plus C.
Okay.
Okay. But this is my favorite standard. And the reason it is because you immediately know that C is the phase shift, and that D is the vertical shift, and the period is 2 pi divided by B.
Okay.
Okay. If you get a function like this, well, notice that the B is inside the parentheses.
Right.
What that means is that that's no longer the phase shift. You have to factor that 4 out so that it reads like this. Well, if I divide everything in there by 4, I'm left with x minus pi over 4. Now, pi over 4 is the phase shift because B is outside the parentheses. Okay? So that's the biggest thing you need to be careful with.
Okay.
And there's no correct standard. It's not like that's any more correct than having B inside the parentheses. It depends on the formula or the equation you get. In other words, they may give you this equation there, which means you got to factor the 4 out in order to get it to this format up there. All right. Let's take these things one at a time, what their implications are. And it doesn't really, we'll work with sine as opposed to cosine.
Okay.
It's really important that you know exactly what the sine curve looks like for a regular sine curve. In other words, the function y equals sine x looks like this, and the horizontal axis, that's 2 pi. That's pi. This is called quartering it, finding the quarter points.
Okay.
And notice that everything that's important about this function occurs at these quarter points. It starts at 0. It goes up to positive 1 at the quarter point pi over 2. Comes back down to 0 at pi. Goes down to negative 1, its lowest possible value, at 3 pi over 2, and back to its starting place at 2 pi. Thus, it has a period of 2 pi. Okay?
Okay.
Let's make one change and change A from 1 to 2. So that y equals 2 sine x. What's the implication of that 2?
It'd start at 2?
No, it just makes the amplitude of the sine function twice as big. So it starts at the same place because the sine of 0 is 0. 2 times 0 is still 0. But it goes up to 2 and down to minus 2. So if I extend this thing down to minus 2, the implications of that would be a vertical stretch. It's actually no different than a polynomial. I'm not quite sure why when they teach trig, they teach it like this is some strange new process. It's not any different at all than if I said, well, what's the difference between y equal 2x squared or y equal x squared? The 2 acts as a vertical stretch factor. And it does change the shape of the curve, notice. Okay? It's not that it looks the same, but it's not really. It's not like I took the red curve and moved it up, moved it down, moved it left, or moved it right. We'll get to that in a moment. But I'm going to take each of these letters one at a time. So the A is a vertical stretch or a vertical shrink. If I made that 1/2 instead of 2, then it would do this. Okay?
Okay.
All right. So let me erase the blue, and we'll take the next letter, which is B.
Okay.
B relates to a horizontal stretch or shrink.
Okay.
Okay? If I say y of sine of 2x, where the 2 goes in front of the x, in other words, now it's like this formula up here, the b is 2, that is going to affect the period of our sine curve. Normally the period would be 2 pi, but the period is actually 2 pi over b. So if b is 2, what's the period going to be?
Half of b.
Well, if I substitute 2 for b, I got just pi.
Oh. Okay.
Right? In other words, over here, my b is 2. Well, that affects the period, and that's the first thing you need to figure out when you know what b is what its period of the new function is going to be. Well, the period is 2 pi over b, so 2 pi over 2 equals pi. So that means I got to draw this whole curve between 0 and pi. And you start by quartering it. Okay? There's the 4 quarter points. And I'm going to draw the entire curve. I'm going to go up to its peak at the first quarter point. I'm going to come back through 0 at the second quarter point. I'm going to go down to -1 at the third quarter point and come up for the fourth quarter point. So all I've done with a B here is horizontally scrunched it. It's like if you could push on the 2 or on the right side of this sine curve to the left, you'd end up with my blue curve. Okay? So A and B both affect the shape of the curve. A is a vertical stretch or shrink factor. B is basically a horizontal or stretch or shrink factor. Those are the hard ones, actually. Even though most people tend to think that the phase shift and the vertical shift are the hard ones, they're really not. Because if you think about it, a vertical shift just takes whatever curve you have and moves it up or down, right? So let's take D next.
Okay.
All right. let's say y equals sine of x plus 1. So that a is 1, b is 1, c is 0, but d is 1.
Okay.
Because all this does is, much like if you had a polynomial and you added a plus on the end of it, it would just shift the whole thing up vertically, right? Well, currently I have a line of symmetry running down the x-axis. Well, so all I do is make my line of symmetry go up 1 and graph it around that. So now I'm going to go up to 2 at the quarter point, going to come back down through the line of symmetry, go down to minus or 0. In other words, instead of going between 1 and minus 1, I'm going between 2 and 0. Come back up to there.
Okay.
Shape of the curve, exactly the same. It's just been shifted up 1 unit. So D is really easy to work with. And obviously, if that was a minus number, I would move that line of symmetry down.
Okay.
And the last thing let's talk about individually, because you can combine all of these things, and that's when it starts to get a little tougher. But let's talk about C. C is called the phase shift. But basically what C does is just a horizontal shift, left or right.
Okay.
Does not change the shape of the curve. If I said the sine of x minus pi over 2, then C is pi over 2. And a positive phase shift means I move it to the right. Okay? Now, the way I used to do my phase shifts was I would draw the non-phase shifted curve, and then I would just take this curve and shift it to the right by pi over 2, so that I would look at something like that. It's not really the best way to do it. Here's the best way to do it. Find your starting point. In this case, the starting point's not at the origin anymore. It's phase shifted by pi over 2, so I'm going to start right there. That's my starting point. Well, what's the period of this function in blue?
The period would be, it would be, what's it called? 2, or it'd be minus pi over 2?
No, that's the phase shift.
Oh.
The period has to do with B. What is B in this problem?
1.
Okay, so what's that make the period? Period is 2 pi over B.
It'd be 2 pi.
Right. Okay, so the way I'm going to draw this graph is I'm going to start at pi over 2 because that's the phase shift. Normally I would start at 0. And now I want to find my ending point. Well, I know 1 full period is 2 pi. So if I take pi over 2 plus 2 pi, I get 5 pi over 2. That's my ending point right there. 5 pi over 2. And that's the way I'm going to draw it, is I'm going to draw my starting point, and I'm going to draw my ending point, and then I'm going to quarter that. Okay? Well, I think you can see that the midpoint is right there at 3 pi over 2. That's the first quarter point. That's the third quarter point. So now I have my beginning point, my ending points, and the 3 quarter points in between. Now it's real easy to draw my curve. I know that I have to start right there. I've got to go up and hit my maximum value right there. I got to come back
Right.
through the x-axis at my second quarter point. I got to come down and hit my minimum at the third quarter point, come back to the x-axis at the last point. Now, basically, I'm going to connect the dots.
Right.
All right. That's each letter looked at individually, one at a time. Obviously, we can combine them, and you're going to have to. I mean, they're going to want you to. But there are two other things that can happen here that I think you're going to have to know, and that is, what is the consequences of a negative sign? Particularly
It
a
would be
negative sign in front, like that. What is it?
Would it be on like the other side of the graph?
A reflection over the x-axis is what that is. Okay, so I'm going to graph the thing in blue. I'm just going to take my graph in red. I'm going to go down instead of up. I'm going to come back there. I'm going to go up there and come back there. So if I reflect the red about the x-axis, looks like that. Okay.
Okay.
So the last thing you can do is put a negative sign in front of the x. In other words, we've covered 5 out of the 6 things you can do. You can have an A, a B, a C, and a D, those 4 things. You can put a negative sign in front of the A, reflecting it over the x-axis, and you can put a negative sign in front of the x. What reflection does that make? That's a reflection over the y-axis.
Okay.
Okay? So
So
that curve would look like this. And notice that I'm only drawing one period of each of these. Okay?
right.
Well, the sine function is an odd function, which means sine of minus x is equal to minus sine of x. So this technically is the same thing as minus sine of x. So it should look just like a reflection over the x-axis. And it does. Notice that if I take this one period that I drew and continue it on, it becomes indistinguishable from the sine curve reflected over the x-axis. All odd functions are, well, not all, but this one in particular, if you reflect it over the y-axis, it looks exactly the same as it would reflected over the x-axis.
Right.
But it's important to understand what the difference is. In other words, the negative sign here is in front of the x. That makes it a reflection over y.
Okay.
And it could make a difference with a complicated function. So, if I add everything together, let's put a 2 there. Let's put a 4 here. Let's put a 1/2 here. Put a pi over 2 there. Let's put a -1 there. So now I've got 4 different things going on to this function. Now,
Okay.
just like polynomials, If you do have any reflections that need doing, do them first, and then do all the other transformations. The order does matter. Sorry, what?
Does that say -1 at the end?
Yeah, it does. And in fact, let's make this a plus pi over 2, just to be different. So the assignment's going to be, how do I graph that curve, that function? Okay. In other words, looking at your pictures here, we got a graph that they're going to ask us how to put that in sinusoid function. So you need to be able to go both ways. In other words, given this, you need to be able to graph it. Given the graph, you need to be able to come up with this. That's standard sinusoid stuff. Okay? And the 2 pages you sent me are both, they gave you the graph, they want you to come up with this, apparently. Or,
right.
I'm not sure here. Maybe they gave you this and you had to figure out how to graph it.
Something like that.
Either way.
I just printed it.
Either way, you need to be able to go both ways, and let's start with graphing from the function. And then we'll take a look at some graphs and figure out how to write the function from the graph. Okay. So what's the best first thing I should do to graph this?
You should look at where D is?
Yeah. In other words, let's redefine our line of symmetry. So where does the line of symmetry go?
At -1.
Okay, so let's draw it. Okay. Where is the starting point of my graph? By the starting point, I mean what normally would be right there.
That would be 2.
No, the starting point has to do with the phase shift. In other words, let's take our shifts that don't change the shape of the graph.
Right.
So C in this case is pi over 2. Excuse me, it's negative pi over 2. So where do I start my graph?
On the other side.
Yeah, right there at negative pi over 2. Okay, so this is my starting spot right here. I'm going to draw a big dot. Okay? Where is my ending spot? In order to figure that out, we need to look at B, because we need to figure out the period. Well, what's B?
B would be 2. No, it wouldn't. Sorry, it would be 1/2.
Okay, so what does that make the period? Period is 2 pi over B. So what's my period going to be?
1.
2 pi divided by 1/2 is 4 pi.
Oops.
Flip and multiply.
Okay.
Right? If I flip the 1/2, it becomes 2 over 1. Multiply it by 2 pi, I get 4 pi. So, if my period is 4 pi, and I'm starting at minus pi over 2, where's my ending point going to be?
It would be at positive 4 pi.
The distance between here and here is 4 pi.
Okay.
That's my beginning and ending point. So
right.
If this is at minus pi over 2, what's this at?
That'd be 5 over 2?
About 7 pi over 2.
7 pi, okay.
Okay, so this point right here is 7 pi over 2, and it might not agree with my red grid, but it's not that far off. So I now have my starting point. I now have my ending point. Well, let's quarter this thing up. Halfway between minus pi over 2 and 7 pi over 2 is...
That would be halfway 3 pi over 2?
Uh-huh. The way you get that is add these things two together and divide by 2. So if I add minus pi over 2 to 7 pi over 2, I get 6 pi over 2. Excuse me. That's all you do is to find the halfway point. Is minus pi over 2 plus 7 pi over 2 is 6 pi over 2, which is 3 pi over 2.
Okay.
For some reason that doesn't seem right to me. It seems like we need to divide by 2, but we'll go with this. I'm going to put my labels down here. That's 3 pi over 2. That makes sense. That's 2 pi away from each end point. So that's the midpoint for sure. And this point right here, this is where I need to add them together and divide by 2. So by adding 3 pi over 2 to 7 pi over 2, I get 10 pi over 2, which is 5 pi divided by 2. This has to be 5 pi over 2.
Okay.
And this has to be pi over 2. Okay? Very important that you be able to quarter between your beginning and your ending point. In other words, the steps you go through to do this, it's significant that we do it exactly this way. You want to do D first, like we did. Then you want to look at B. And then, well, or C rather, we did C second, and then B. So we basically figure out everything in complete reverse order when we go to graph. We start with D, then we consider C, then we consider B, and last we're going to consider A. So I've got the line of symmetry, I've got all my quarter points, I know it's going to start right here. Where does it go to at the first quarter point?
2, because that's
it goes up by 2, which is this point right there, right? In other words, remember the line of symmetry is at -1, so I have to go 2 units up and 2 units down. So I'm going to have to draw a little bit more of this thing in order to illustrate this. So I've got to go through this point right there at pi over 2 and +1. I'm going to come back through my line of symmetry right here, the middle quarter point. I'm going to go all the way down to what at my bottom?
-3.
So I've got to get down by the 5 pi over 2, I got to get down to here. And then by 7 pi over 2, I got to get back to there. Now it's just a question of connecting the dots. Notice this curve is flatter. It's been horizontally stretched, as well as vertically stretched. And notice the oddity of that. It was vertically stretched because that 2 is greater than 1. It's horizontally stretched because that number is less than 1. So horizontal has the opposite effect of vertical. When you have A greater than 1, it's a vertical stretch. When you have it between 0 and 1, it's a vertical shrink. But when you have b greater than 1, it's a horizontal shrink. When you have b less than 1, it's a horizontal stretch,
Okay.
like this one was. Okay, now let's look at what you sent me here and see if we can go the other way here. How do you take this curve and end up with that? Well, you start by doing exactly what they do here, and that's to define A, B, C, and D. Okay? How do we get A?
Let's see here. You get
By looking at the curve, how do we get A?
by looking at like the top point.
Take your highest point, subtract your lowest point, and divide by 2. What's the highest point on the y-axis here?
That would be at
What's this point right there?
that is, let's see, 1, 2,
It's labeled
3,
right there.
4, 5.
Okay. What's the lowest point?
-1.
What's 5 minus minus 1?
6.
That's how we get 3 for A.
Gotcha.
And this is kind of important because if they give you a word problem, like a tides problem, they'll give you high tide and they'll give you low tide. Well, to figure out A, you take the high tide, you subtract the low tide, and you divide by 2. That gives you A.
Okay.
To get D, you take your highest value and you add your lowest value and divide by 2.
Okay.
Okay, so A and D are kind of similar in that respect. And one case, you just take your high minus your low and divide by 2. In the other case, you take your high plus your low and divide by 2.
Okay.
Okay? B. B is 2 pi over the period for the same reason that when we were looking to figure out the period, we took 2 pi over b, right? Those two things mean the same thing. In other words, one is just algebraically manipulated of the other. So to figure out b, I need to figure out the period. Well, how do I figure out the period? You can take any 2 points. You can go peak to peak. You can go trough to trough. You can go that point there to that point there. But you have to figure out how much the period is horizontally.
Right.
Well, it looks to me like it goes 3 units from this peak, which has an x-coordinate of 5/8, I believe, to this trough, which is 3 5/8. Well, that's only half a period, right? In other words, the period, I'd have to get back up to that. So half a period is 3, so the full period is what?
Half the period is, okay, I spaced out there for a second.
Okay. We're measuring the period from what they've given us here. And they tell us the x-coordinate of this point right there is 5/8.
Oh.
Okay.
So.
They tell us the x-coordinate of that point right there is 3 5/8. Well, that represents half of a period, not a full period. Well, so if half of a period is 3, then the full period is 6. And if the full period is 6, then B is pi over 3.
Okay.
Not what the green thing here says.
Okay.
Now, I'm not sure. Who put these blue labels?
That's my math teacher. He made all those notes on his whiteboard. Or not whiteboard, but smartboard.
Am I misreading this? Is that 3 5/8, or is that's 3 pi over 8? And that's pi over 8. Okay, let's go back here. I was misreading these. So, the period is what? If that's pi over 8, and this is 3 pi over 8, what's the difference between those two?
2 pi.
2 pi over 8.
Right.
But that's only half a period. So instead of 2 pi over 8, 4 pi over 8 is the period. That's why he said the period is pi over 2. That's 4 pi over 8. Okay? So from reading the graph, we know that the period is pi over 2, and therefore B, which is 2 pi over the period, again you have to flip and multiply, which you have to do a lot with the sinusoid function, because the period is very often a fraction. So you have to know how to simplify that. And you can tell that if I flip and multiply, I get 4. So that's how we got a B of 4.
Okay.
Okay. And the last thing we have to figure out is how we get C from this graph. Well, notice that this thing is not shifted horizontally at all. In other words, if I draw my sine curve, you start at the origin, you go up to the maximum, you come back down through the origin, you go down to the minimum, and you come back to the x-axis. Okay. Well, if I drew a couple of these periods, it would look exactly like that looks, only that's been vertically shifted up by 2 units. But other than the vertical shift, there's no horizontal shift going on here. It's a horizontal shift, might look like this. In other words, if I looked at a curve like that, the phase shift is that amount between there.
Okay.
Okay? So you have to look at what it looks like, and it also looks exactly like a positive sine curve starting at this point here. As you've probably figured out by now, with phase shifts, a sine curve is the same as a cosine curve, right? In other words, if I take, let's take a sine curve, where this right there is pi over 2. In other words, that's your regular sine curve. But let's phase shift it in that direction by pi over 2. Well, what does it become? It becomes the cosine curve. This is a cosine curve now. Hold on, let me draw it a little bit better. So this red line right there, which I could say, okay, that represents a sine curve that's been phase shifted to the left by pi over 2. So that is a sine curve that's phase shifted. But it's also exactly a cosine curve. So the sine of x plus pi over 2 is the same as cosine of x.
Okay.
Meaning that you can take any graph that they give you and you can actually come up with an infinite number of sinusoid functions. Because I could call this a cosine curve that's phase shifted by pi over 2. I could call it a cosine curve that's phase shifted by 2 pi. So there's not just one unique solution.
Right.
But the important thing is to use the trig function that results in the least amount of phase shift. In other words, it would be crazy to take this curve and phase shift it by this pi over 8 amount to the left to make it look like a cosine curve. But I could do it. In other words, instead of coming up with the final answer of this, I could also say, well, that is also 3 cosine, doesn't change the 4x, but if I phase shift it by pi over 8 to the left, I would have the cosine curve. So this is the same as this. In other words, the cosine curve and the sine curve are the same curves. It's just one is phase shifted relative to the other.
Okay.
And so if you have a choice as to which function to use, in other words, it's called sinusoid function, but you would never want to use sine if you could use cosine with no phase shift. You know what I'm saying? In other words, if I give you this curve right here, I'm going to call that cosine of x, even though I could call it sine of x plus pi over 2. In other words, if I take, x minus pi over 2. Because if I were to take this curve here and phase shift it to the right by pi over 2, it becomes the cosine curve. No, I was right in the first place. That's a plus. In other words, if I take my sine curve, which normally looks like that, and I move it to the left by pi over 2, well, this point here is going to start right there, and it's going to look exactly like the cosine curve. So the net of that is that given either a curve like this, a graph, or a real-life problem like a Ferris wheel problem. Have you had any real-life problems that they've given you? Like Ferris wheel problems, tides, breathing, anything that is periodic in action. In other words, a sinusoid function models the tides perfectly because the tides are repetitive. They repeat. They don't repeat on a 24-hour cycle, but they repeat on like a 23-hour cycle or something, if I remember right. So their period wouldn't be 24 hours, it would be 23 hours. All right, let's look at the other one that you sent me here. We'll figure out how we come up with that. Taryn, you still with me? Taryn? We lose audio? Taryn? Ah, there you are. Taryn?
Yeah, sorry about that. I don't know what happened.
Okay, I lost audio. I was calling you.
Oh,
Okay,
sorry about that.
so let's take this curve and see how they came up with this sinusoid function.
Okay.
How do I get A?
You get A by where, by the highest point of the curve
Minus the lowest
minus the lowest point.
divided by 2.
Right.
So the highest point is 75. The lowest point is 3. 72 divided by 2 is 36.
Right.
Okay. How do you get D?
D you get by, why am I drawing a blank?
Highest point plus the lowest point divided by 2.
Right, okay.
Okay. And it's useful to have a way to figure out, because I've found myself before forgetting which is which.
Right.
Okay, well, let's take your standard sine curve, and I'll help you figure out how to remember. What is A on my standard sine curve?
1.
Okay, how do I get that? Well, 1 minus a minus 1 divided by 2 equals 1.
Oh, okay.
Okay, what is D on my standard sine curve?
-1?
0. There's no vertical shift.
Oh, yeah.
Okay.
Right, sorry.
How would I get that? I would take 1 plus minus 1 and divide by 2 to get 0.
Okay.
So if you forget how to come up with A or D, just know this and know that to come up with A, you got to divide, you got to take that point minus that point, divide by 2. To come up with D,
Okay.
you got to take that point plus that point, divide by 2.
Okay.
Okay? So we have A and D are easy to come up with. Let's come up with C next. No, let's come up with B. To come up with B, you got to read the period from the curve. What's the period?
The period would be 4 pi.
No, look at it. It's the distance between that trough and the next trough.
Oh, so, I can't see. That'd be, is that a 3? A 3
No. Read the x-axis, the horizontal axis. That has to do with the period and B.
Oh, 0 and 1/2.
Okay. So the period is
There you
1/2. Okay?
Okay.
So what is B?
B would be,
It's 2 pi over the period.
yeah, 2 pi over the period divided by 2.
2
Right?
pi over 1/2.
Okay.
Which is?
Sorry, I'm tired. That'd be 4 pi.
Okay. So that's B. So we got A, we got D, we got B. Now, to figure out whether we got a C or not, is this thing horizontally shifted?
Yeah.
Well, it might look like it is, but in reality it's not. What it is reflected over the line of symmetry. It's the cosine curve reflected over the line of symmetry. Notice the cosine curve, and this is the way you want to remember these. The cosine curve starts at its maximum,
Okay.
goes down to its minimum, comes back up to its maximum. Well, this curve here starts at its minimum, goes up to its maximum, and comes back down to its minimum, which is an exact reflection of this over the x-axis. So there is no phase shift, there's just a reflection. And that's how they come up with the minus sign in front of the 36, is that this is the cosine curve reflected over its line of symmetry. So our A is 36, but a negative 36.
Oh, okay.
B is 4 pi. C is 0. And D is plus 39.
Okay, now I see that.
And that's really, had this curve, let's move this curve to the left by 1/8 of a unit. Okay? Now it starts right there, right? In other words, if I take this curve and move it to the left by 1/8 of a unit, this point that I'm pointing at right there becomes right there. And I end up, it looks like this. Well, that's a sine curve. So this curve, I have a choice. I can call it a negative cosine curve with no phase shift, which is what they did. Or I can call it a sine curve that's been moved to the right by 1/8. So I could also say it's the sine of 4 pi x minus 1/8 plus 39.
Okay.
But I'm not ever going to do this because you don't use a phase shift if you can classify it without a phase shift. In other words, I was able to call this a negative cosine curve, which it is, with no phase shift. It also happens to be a sine curve with a phase shift. But the general rule of thumb is that you use whichever results in the least phase shift. Using the cosine function resulted in 0 phase shift. So I'm always going to do that, as opposed to a sine curve that has a phase shift of 1/8. See why that is a sine curve phase shifted by 1/8? Because if I took my sine curve and moved it to the right by 1/8, this is what it would look like. Here, if I take a normal sine curve and move it to the right, that means it starts right there. Well, that's what this does, is it starts right there, 1/8 to the right. In other words, move this whole thing back to the left and it looks just like a sine curve. But that would be a phase shift if I wanted to call it a sine function.
Okay. I'm slowly starting to get it.
Okay. Well, it's a little tough to get, but probably I think one of the most important things to remember is that it's really no different than a polynomial. In other words, if we started with y equal x squared, parabola, y equal x squared, well, I can modify this thing in a variety of ways. I can put a 2 in front of the x. I can put a phase shift there. I can put a d on the end of it. So now, here's my vertical stretch factor. Here's my horizontal shift, the phase shift factor. Here's my vertical shift. The only thing I don't have is a number in front of the x. If I put a 6 in front of that x right there, well then I also have a horizontal stretch factor. So everything that I can do to this polynomial equation, y equal x squared, is really no different than everything they're doing to a sinusoid function.
Okay.
They just call them different words. They call it phase shift instead of a horizontal shift.
Gotcha.
They call it amplitude instead of a vertical shift. They call it B, and period change instead of a horizontal stretch or shrink. But
Just trying to keep that.
well, and I think it probably does the job with most people because they do not teach it, even though the very preceding subject you might have had was translations on polynomials. They don't call that this. They should, I think. That's all it is, including the negative signs. That's a reflection over the x-axis. If I put that x in front of the cosine here, it's a reflection over the y-axis if I put a negative in front of that x.
Okay.
Okay? All right.
Okay.
Well, I can't think of anything else to add.
Okay.
The best,
Yeah, we'll go over in class 2 tomorrow.
okay. The best thing we could do, if you really want to get this down, if you have another session with me before you have to be tested on this, is to give me a bunch of problems going both ways. In other words, give me the formula, we'll graph it, or give me the graph and we'll come up with the formula. You're going to have to do both.
Okay.
So,
Yeah, we're going over this next class. These are the notes for next class.
okay.
So I'm just like
So
getting
this is-
ahead. He
yeah,
said it.
so this is kind of warming up for it. Okay, well hopefully this will help you a lot.
Yeah,
But
we'll see.
the thing that will really help you is practicing. In other words, what we
Right.
did not do tonight was have you do problems. Basically tonight was me lecturing the whole hour about how to do this. And that's fine. You
Well,
have to
you
learn it somehow.
Yeah.
But you're really going to learn it by you doing it.
Okay.
In other words, you need to do some homework transferring the function to a graph or reading a graph and coming up with the function. You just need to do some homework problems and you'll get it once you do a few of them.
Okay.
Okay? Right there.
Will do.
I will talk to you next Monday.
Sounds good. Thank you so much.